Good morning. Thanks, Thambu. Thanks for the opportunity. It's a great feeling to be back. And I'm going to talk to you about the topic which raised a question nearly 25 years ago to medicine department when Dr. A.M. Cherian was the chair of the department, that he was doing that P2AM, polydimethyl oxide for organophosphorus poisoning. I understand that the question was that he had the question as high dose versus low dose polydimethyl oxide for organophosphorus poisoning. So that is how we evolved. So we did not know how to address that question. You can't say that the low dose is better than the high dose. So that time we did not know how to address the question. So we were falling on McMaster University to help us to analyze such data. That time the concept was equivalent studies. As at the maximum you can say that low dose is as good as high dose. So that is how you need to approach, and we do not know how to analyze and address the data. I still remember we need to analyze and send the data to through the fax machine, then he'll correct and send it to us to the CU by fax machine. That is how we established communications. Over time, as you see here, the non-inferiority trial designs evolved. So that replaced almost the equivalence concept. So that is what we are going to discuss now. It's very interesting to see the evolution of these designs. So the first one is then our eyes were opened. We started looking at the questions very carefully and analyzing the data properly. One of the such designers, we start up with the equivalence study. So Dr. Srikanth Thambu acknowledged, he's a great teacher from Professor of Biostatistics from University of North Carolina, moved over to McMaster now. He is a great source of inspiration and good teacher. He came almost every year here to train us in clinical trial concept. And so we gained a great amount of knowledge from him. I'm going to use most of his slides. This is a very important concept. That is, as I said, we did not know how to address that polydimethyl oxide or that time, and later on many such questions. So this is 3 days versus 5 days treatment for non-severe pneumonia in children with children. This is if you look at the objective of the study, this is that we said our primary objective was to compare the proportion of children. That time we had Thomas Cherian, who is in WHO now. He was here in the pediatrics department. If you see, so that time we were very clear how to phrase the question. So if you have no idea about equivalence trials and non-inferiority trial designs, that we simply say we wanted to compare. When you say compare, it is a clueless, directionless concept, because you have no idea about whether it is going to be as good as or non-inferior to the existing standard of care treatment. So that is what meaning compare. In superiority also you would say compare, but in superiority you would say one is better than the other. So you have three concepts. One is better than the other, another one is as good as the other one is non-inferior to the other. So how people have been addressing these questions of equivalence over these years prior to 2000. So now we have changed and we are very clear how to address this concept. And this is based on equivalence trial. There's another professor called Stephen Walter who helped us. So he was a consultant for this project. This is a very big study with the 2,000 children randomized. I remember I did the randomization here, and the placebos were done in Vellore for 2,000 children. It was a big study and funded by International Clinical Epidemiology Network. This is the data of 2,000 children. And this is, so see here, I'm just giving you the concept. Tambu explained the confidence interval concept to you. If you take the efficacy is cure rate on day 3. The 3-day arm is 89.5%. This is 89.5%, and the 5 days arm is 89.9%. If you look at the difference, it is 0.4%. Okay. Until then, we know only superiority design. So if we say 0.4 is very small, and it is not going to be statistically significant. And therefore, we would conclude that 3 days is as good as 5 days. That is not the concept that we have today. That is a wrong concept. If you don't reject the null hypothesis, don't ever accept the null hypothesis. Please remember, this is very important. This is what happening over the years prior to 2000, that if there is no difference, we simply accept the null hypothesis and say one is as good as the other one. Okay. So now the things have changed. See here, this is the confidence interval is 0.4% is that difference. It could be as low as 2.1%. When I say 2.1, as low as 2.1%, usually we calculate the difference of the new intervention minus the standard of care. Please remember this, don't change it. All my slides, I'm going to talk to you about the new intervention which you are talking about minus the standard of care intervention. So when you see a minus sign 2.1%, which says 5% to 5 days arms is better, because that is where you get the minus sign. The efficacy that could be slightly better, 2.41% more in the 5 days arm. That is what it means. When you look at this side, the 3 days arm may have 3% more efficacy as compared to 5 days arm. That is why you get the plus sign. Do you understand why plus sign? Plus sign is the new treatment is more. That is why you get plus sign. What we need to look at is, but we don't go into the detail of interpreting that, what is 2.1%, 3%, and so on. Your eye should look at whether it includes 0 or not. Does it include 0? The confidence interval? The confidence interval includes 0. The moment you see minus sign and plus sign in the confidence interval, that includes 0. That means first message is that it is not statistically significant. Then how do I interpret the data? Okay. Now you see, you don't see the p-values here. But this is a BMJ. I think 2004 or sometime that the paper was published. So we concluded that as this included 0 in between, there is no difference between the two arms. But I showed you the slide which said the hypothesis was this is equivalent, to be equivalent. See here. So the hypothesis was to be equal. So one is as good as the other. You should ask the question, did we have an equivalence margin? Did we have an equivalence margin? So we need to see all these things as we go ahead. Okay. And okay. So now this is, there are many other, the relapse after 5 days and so on and so forth. All these parameters suggested that 3 days is as good as the 5 days. Okay. So because we got involved with McMaster University, that they were able to phrase the questions correctly. Otherwise, we would say there is no difference between the two groups. Therefore, we will accept the null hypothesis. What is the null hypothesis? 3 days is equal to 5 days in terms of cure rate or whatever. So you don't reject it. So therefore, you will accept it. So if you see here, to how did you decide the sample size based on the equivalence concept? That is what we are going to tell you. Now, this is another study, which is, I remember in CMC history, this is a third paper in New England Journal of Medicine. So 3 people from our department got involved. This is about aerosolized vaccine for measles as compared to subcutaneous route. This is okay. This is non-inferiority trial involving children. So clearly phrased, this is non-inferiority. Okay, this is an evolution from equivalence to non-inferiority. Okay, shall we phrase this as that aerosolized vaccine, that zero conversion rate is as good as the subcutaneous route zero conversion rate? Why did we phrase it as non-inferior? Okay, so the non-inferiority design, the moment you see a question, it is very clear one is inferior. When you put the vaccine, it's a spray, a lot of vaccine goes into the air, that actually the efficacy has to be inferior to subcutaneous route because 100% vaccine goes inside. Do you understand? So therefore, if you are very clear that one is inferior, it has to be based on non-inferiority design. It's a very simple concept. If you're not sure, directionless, clueless, like 3 days versus 5 days, and so on and so forth, if you don't know the direction, then probably you would go for equivalence. Definitely that it is not superior. Okay. This is something. So this is the data which we presented. Now this is, you see here, again you don't see the p-values. Corollary to this map is that we need to learn to read the confidence intervals and interpret the message from this. The first one is whether the confidence interval is narrower or wider. Does it include the null hypothesis value? The null hypothesis values varies from equivalence trial to non-inferiority trial and so on, superiority trial. So therefore, you have to have some idea about what is the margin that we are talking about, what is the null hypothesis value here, and how do I interpret the confidence interval. That has to be the message. So end of the workshop, you should be able to address all these things, correctly identify the question, and establish the margin, and don't worry about the p-values. Do simple confidence interval as come to present at the formula, that do this one and decide whether suggest equivalence, non-inferior or what. Okay, so I got involved in the study. I was made as a member of the DSMB, Lady Harding's, many years ago. They wanted to do a study in UP that because in the village, rural area, they were not able to get the WHO formula powder, the milk powder. So therefore they said that we'll train the mothers to boil the milk, cow milk very well and study the efficacy of the cow milk as compared to the WHO based formula. So the objective was to compare the time taken for 25% weight gain during hospital stay of children who received intervention as compared to intervention Y, that is a WHO the formula. So you have, so this is definitely cow milk is inferior as it stands because they have to carefully use it and so on and so forth. Nevertheless, it is a good hypothesis. The intervention X is as good as intervention Y. Is it correct? Or it should be non-inferior? Non-inferior. Okay. So I'll correct this slide. So this is the group, the discussion, they said it is as good as this. This is not my wording, that is their wording. Look at the sample size calculation, which they did. The mean SDR proposed weight gain would be achieved in 20 days, considering 3 days as statistically significant reduction. Can you see this one? So that means one arm, that the WHO formula powder, whatever, will have less time to gain this weight. You understand this? So this is, when I say less or more, it's called superiority hypothesis. Do you understand the phrasing? So this is basically wrong. So this is, we corrected them, and the team, that the question was asked, how do you conclude? This is that the hypothesis is to show as good as the other one, but the sample size calculation was based on superiority concept. How do you, at the end of the analysis, you do a t-test or whatever test you do and say no difference? How do you conclude one is as good as the other? Let's say if there is no difference, we'll conclude cow milk is as good as that formula. Do you understand? That should not be done. This is what happening everywhere. I remember a senior faculty in anesthesia department. I said, Madam, you should not accept it like that. So this is not correct. No, Jeyaseelan. So all the articles from our journals are like that only. You also write the interpretation like that. So this is happening everywhere, that you don't accept, don't reject the null hypothesis, conclude that one is as good as. Tambu said that when you say there is a difference and you don't reject it, why? Because you studied less number of subjects. Power. So when you do not reject it, you have to ask the question, what is the power of your study? Have you studied enough number, or have you studied less number? The less number is a cause for no difference. It is not really there is no difference. You have not studied the right now. So this is how people do studies. Oh, this is going back and forth. So this is what we are saying. So no difference, and at hypothesis there is a difference. Do not reject the null hypothesis and do not accept the null hypothesis. There is no concept of accepting the null hypothesis. So in science. So how do you phrase the questions? So that is what we are going to see. Many people don't like this slide, because someone said, how do you go about doing the study when you wanted to accept the null hypothesis? So let me give you this example. This is a hypothetical example where that the psychiatrists were, the community health workers were given 6 months of training to treat psychiatric morbidities in the community. Okay, because it's very difficult to get psychiatrists working in the community. Therefore, the ministry thought, so we'll train community health workers to treat psychiatric morbidities. So this is the concept. So the idea is they wanted to show that community health workers in treating the psychiatric morbidity is as good as psychiatrists treating the psychiatric morbidities. This is the data. Can you please look at the data and tell me what is going on? And it is not statistically significant. So let's say that the optimal cure was 40% by community health workers. The optimal cure was 63% by psychiatrists. The difference 23% was not statistically significant. Therefore, they concluded that community health workers are as good as psychiatrists. Is that right? This is what will happen if you accept the null hypothesis. Many places, this is what happened. Therefore, they started training community health workers. First of all, phrasing the question is not correct. You cannot say compare. So that means you are not very clear. At least you should say that community health workers are non-inferior in treating psychiatry. Maybe they did not know the science at the time. Okay. This is a bad example. So negative study. This is why you have to do the why this is not significant. 23% favoring psychiatrist. Why this is not statistically significant? So you work backwards for this data and study the sample size. Okay, so this data should have studied 75 subjects in each arm, but they studied 35 subjects in each arm. This is R.A. Fisher, analysis of variance. So it's called Fisher is called the father of statistics. He's a philosopher, big statistician, and he said never proved or established. Null hypothesis cannot be proved or established. Okay. So how are we going to address the equivalence concept and non-inferiority concept in science? So now I'm going to talk to you about how are we going to look at the concept of the confidence interval. It's easy to construct a confidence interval rather than doing a p-values. So in your system, SPSS or anything gives you standard error, you can multiply it by two times the standard error, add it with your mean, add it with your proportions, and subtract it with the proportions. Simply easy than doing a t-test or chi-square test. So we have three designs. One is superiority, equivalence, and non-inferiority. Superiority trials, what we are saying is the effect of one treatment on a certain endpoint outcome is superior to that other. So don't use the word compare. The moment someone reads your objectives, is saying that this is the mortality is expected to be significantly lower as compared to the other arm. Okay. So this is what you do as an objective. So when I read your paper, I know this is superiority study instead of saying compare. Now, this is the placebo control trials. So I'm not going to talk about a placebo control trial. It's very rarely done. One active treatment is superior to another active therapy with respect to a certain endpoint. So this is what we have in mind. We write this. This is the T is the new treatment and R is the reference treatment. Difference in the mean 0. That is your null hypothesis, and the alternative hypothesis is no difference. Alternative is no difference. So what do you do if you don't find any difference, statistically significant difference? You work backwards and see what is the power of your study. Do the power analysis. So power analysis is nothing but how many subjects I should have studied given that difference. Okay, this is what we said. What do you do? This is your standard error. This is the difference between the two arms. This is 1.96, approximately 2 times the standard error. Okay, calculate the confidence interval. So every subject, every software gives you this. And it's easy to do. This is what you should get. In a superiority trial, what we said was, I remember I highlighted the 0, the null hypothesis value. The null hypothesis value is 0. So the superiority trial, one is better than the other. The null hypothesis value is 0. This is 0. So your confidence interval should avoid the 0 to say one is better than the other. Any questions? Do you understand this? I construct a confidence interval and see either it has to be positive or either it has to be negative, both values. The lower limit, upper limit should have plus sign, or lower limit, upper limit should have negative sign. Okay, do you understand this? Okay, so this is what, so moment you look at the graph and you say this is superior, one is superior. If it includes 0, the confidence interval, you say it is not statistically significant. Then you do the power analysis and see. So equivalence and non-inferiority designs, we'll see equivalence designs. Now, what I wanted to tell you is, this is what we have been discussing. Please remember this. This when you go back and teach your juniors, that this is 0, this is your confidence interval. This is significant. So if overlaps, this is not significant. So now we are saying, if this is not significant, you cannot conclude equivalence. This is wrong. So remember the psychiatrist and community health worker example, we cannot conclude that both are equal. I am going to come back to this concept. It's a very important concept. Now we are talking about equivalence trials. So the effects of two treatments and certain endpoints, for example, mortality or whatever, differ by no more than a pre-specified amount. Okay. So this is, say for an example, you are very clear that A may be better or B may be better. We are not very sure, or both are equal here. Not better. Their effect is nearly similar in both arms. Slightly better here or slightly better there. So therefore, we are talking about this type of confidence interval for equivalence studies, and should have 0 in between to say one is as good as the other. You need to decide the sample size. If you study a small sample size like the community health study, and obviously it will overlap because your sample size is very small. You need to decide your sample size. To decide your sample size, you need to define your equivalence margin. Okay? Now, when I say the equivalence margin is like this, say for example, are you happy about this margin? The margin always has to be very narrow. This is undependable, not really impressive confidence. It has to be very narrow. You say either this end or that end, it doesn't make any sense. It's very important. Therefore, you need to fix this margin, equivalence margin. This, I am using a specific notation here. Say for example, 5% minus 5% or plus 5% and mortality. Okay. So you're fixing, this is a priori when you define your equivalence, because that helps you to decide your sample size. We are going to do some exercises. Now similarly for the other non-inferiority design also. So that we are not going to do this lot to lot consistency. This is what the factories industry will do. So this is, do we have examples? Do we have a good amount of examples? So the amoxicillin study for non-severe pneumonia was based on equivalence concept. We can repeat that calculation and see whether we are able to come back to the same number. Okay. This is basically, you see here, minus delta and plus delta. Sometimes the people will say this too one-sided. What is too one-sided? The difference can be here or the difference can be here. So here 2.5% and here 2.5%. Therefore, put together it is 5%. So this is the industry. The industry people talk to you about this too one-sided hypothesis. Basically, just simply remember, again, it is the 5.5% is the error, 95% to calculate. This is something, so don't worry about the notation. It comes back to this. I use the limit delta for equivalence. So this is what equivalence is. Can you see this one? When I see this, this is, say for an example, I don't know whether you can see this one. This suggests equivalence because it falls between these two limits, delta. And I would say, what if I'm given a data, I would look at that if any one of the limit has crossed the margin or not. Both the limits are within this margin, therefore it suggests that equivalence. Okay. Suppose you find a limit here, both are both the limits have exceeded the margin, therefore it is not equal. Is that right? So the confidence interval should fall between these two limits. Then you claim that it is equivalent. So the margin is a priori. Many times after doing the study, people will change the goalpost. I would say 5% minus, say for example, slightly bit wider. So this is, I get here, this is 7%. Then I'll say my margin is 10%. You can have 7%. But that is so long that 10% is acceptable. Okay, but you will not know that kind of thing. I'll show you some of this thing. This is not significant, not equivalent. And this is not equivalent. Because one limit has exceeded the margin and therefore it is not equivalent. Is that okay? What all you have to do is you have to calculate the confidence interval. Okay. Now, so therefore, the superiority is the one where, please remember, we are going to talk about three designs. All these designs will calculate confidence interval. This is superiority. It excludes zeros. It excludes zero and it is superior, significantly superior. This includes zero to say equivalent. If any one of the limits exceeded the margin, you would say it is not. Now, this is any question. On the other hand, non-inferiority design. Please remember, I told you the simple rule is that when you phrase the question like a cow milk versus the WHO feed formula, you know one is inferior. Community health workers are expected to be inferior. So therefore, it has, your design has to be non-inferiority design. You don't even because equate to psychiatrist. You understand? So the moment you say something is inferior, you know, the aerosolized vaccine, you know this is inferior. So then you say it is non-inferior to the comparator or inferior to the comparator. So something non-inferior to the comparator. This is what we are talking about. So when you decide this one, this is very important. This is equivalence, non-inferiority. There are reasons why we are doing a non-inferiority trial. Now, can test for superiority of tests treatment simultaneously. What does it mean? One advantage of doing non-inferiority trial is that you can show equivalence, you can show superiority. You understand what I'm saying? Say for example, here you do a non-inferiority trial. This is my design is non-inferiority design. This is my margin. Okay? I don't care about the positive side of it. Minus interest is, I know it is inferior, therefore I am interested in the lower limit of the confidence. If there is a difference, what would be the lower limit of the confidence interval, and whether that exceeds this limit or not. End of the study, you find the difference, your confidence interval falls here. What does it mean? Superior. When we started off with the saying that non-inferiority, the superiority studies, you do a superiority study, this is superiority study, and the confidence interval was like this, you don't conclude equivalence. You understand this? You cannot come this side. You understand this? This is, on the other hand, if you plan a non-inferiority study, you can show equivalence, you can show superiority. There are many examples like that. So what does it mean? On the safer side, when you phrase the hypothesis, carefully phrase the hypothesis, it might give you an opportunity to show superiority as well as equivalence and then superiority. Okay? So now this is very important. So therefore, when you design a study, you just ask for it. What do I want to do? So therefore, except superiority, equivalence can show superiority, non-inferiority design can show equivalence and then superiority, not the reverse of it. You understand? This is very important to remember that. So non-inferiority, you see here, this one is a limit. This is the limit. The lower limit of my confidence interval has exceeded the a priori margin. Therefore, it is inferior. Do you agree with me? So therefore, I wanted to tell you that when you establish a confidence interval, look at the non-inferiority designs. Look at the lower limit of the confidence interval and see whether it has exceeded the margin or not. If it has exceeded the margin, it is inferior. Okay. So long within this margin. Now, say for an example, we'll show you a lot of other examples. Now, what do you conclude this? Supposing I say my margin is like this. This is non-inferiority margin. Non-inferior. I would look at only the lower limit of it. Okay? The process, supposing if I get by luck, if I get a confidence interval, what does it say? We planned a non-inferiority design, and then the study we showed superior. So therefore, this can happen. So therefore, you need to look at the lower limit of the margin and whether it has exceeded that one. Very simple, you say inferior. Yes.
So this, we worry about how much it is going into the superior side.
No, we don't.
We are not worried.
Yes.
Sir, are we not for showing that it is actually not inferior? Shouldn't both limits be beyond the inferior, not the margin?
No. Let us go back and see what is the meaning of the confidence. What is the meaning of the confidence? The meaning of the confidence interval is the population difference could be as low as this limit or as high as this. The population difference will fall between these two. So, because in the non-inferiority design, so we are on the lower side, I just look at only the lower side. It has crossed means the difference can sometimes that can be as high as low as this much in the long run. That is the use of this confidence. If you look at this, the way we are presenting the data with the confidence interval, not the p-values. So therefore, we need to understand the concept of confidence. If you're talking about the difference between the two arms, in the long run, the difference could be as low as this much. So if it is exceeded, there is a possibility that it can exceed this. So therefore, I'm cautiously concluding that it could be inferior. The meaning of it. Now, I remember I was helping International Vaccine Institute. There was a vaccine study which was done in because they have this non-inferiority studies because, but so they said, but then I can show you the data that they concluded there is, because this is the limit was like this. How do you come? Non-inferior? Any other solution? It suggests equivalence. Non-inferior is correct because it is within this margin, but it also includes zero in between. The typical non-inferiority margin is this. Typical is, this is non-inferior margin. So your eyes are expecting that kind of thing. What I'm saying is, that is correct because that is within this margin. Also look at the zero, zero gets included in this, and therefore I would say this is not only non-inferior, suggested that it is equal, which is much more better information. I'm just saying that. Please remember, it allows you to conclude non-inferior to equivalence. Sometimes it will be equal to non-inferior. So this is, so therefore we look at some of these diagrams and see. And they could not understand what I was trying to tell them. I said, I'll interpret as a statistician your data. I interpreted and sent it to them. Okay? When you say which is much more better information, that this form of vaccine is as good as the other one, even though you phrased the study as it started off the study with a non-inferiority design. So this is what we are discussing about. This is on the non-inferiority poor outcome. So let us not worry about it. Talking about the positive side of it. This is the data. There are 2 time points. Proportion of patients with no pain, 48 hours, 12.5%, 10.8%. The new treatment had 12.5%, no pain, 10.8% in the standard of care. The reference. So pain, 50% pain reduction at 48 hours. This is the data. The margin is 10%. So you look at the confidence intervals. So what would you suggest for no pain? Non-inferiority as well as equal, because it includes zero in between or not. Am I confusing you? Let us get confused and then we'll come back. So this is, say, for an example. This is 0 minus 10%. That is minus 7.6%, minus 7.6%, let's say 8% or 7.6%, and goes up to 11%. Okay. So what is the question here? So now pain and what is the question? What do you conclude? So first of all, it is non-inferior, yeah, because that this margin is within 10%. So can I conclude the equivalence? Yes. So equivalent also because this includes zeros. Typically, strictly speaking, I would conclude strictly as non-inferior if the margin is like this, not including zero.
So for clarity, can you just tell what is that x-axis?
X-axis is your difference. X1 bar minus X2 bar or P1 minus P2. Proportion, say for example, mortality rate, one arm versus other. Could be anywhere between 0 to the side infinity or 0 to minus infinity.
So for a given study with two interventions, you will only have
One
line
one
with
line.
2 points on the x-axis.
Difference. We are taking the difference. So whenever statistics delta, they are talking about the difference. Difference. So this is basically, though it is a non-inferiority concept, what is the next one? Inferior. Because it exceeded the lower limit, minus 10. Minus 16 is your value. You understand this? So many times, if you take New England Journal of Medicine, lots of studies are dealing with non-inferiority equivalence based. So then if you look at the graphs, you would be able to see it. Okay? Now I'll go back and show you now we'll come back to this again. The WHO wanted to have a non-inferiority margin of 5%. Zero conversion rate, 90% was fixed. Non-inferiority margin was 5%. Look at each outcome, that is per protocol analysis and intention to treat analysis and so on. The various ways of doing the analysis. Okay. And the results are given to you. When you look at the average difference between the two arms was aerosol arm and subcutaneous group, the difference was minus 9.2%. And the confidence interval is minus 12.2 and 6.3. What is your margin? Margin is 5%. Non-inferiority margin is 5%. Now you tell me what is going on.
Inferiority.
So one group suggested in the discussion shall we change the code to 10%. So they wanted to be very strict. Now let us leave it like that as 5%. So as it stands, according to 5%, it is inferior. The aerosolized is inferior to subcutaneous group. You understand? There is no p-values, nothing. So this is what you have to do. And they have given the directions here. Okay. Now I'll go back. So this is what this is inferior, then this one is non-inferior, and this is superior. See? So this can show you the superiority as well. So therefore, this is a very important design. And this is for the poor outcomes, the complement of it. When you say zero conversion or no zero conversion, if you take that, it's the other side. Let us not worry about it. This is what we have discussed. Many times we ask the question, how do I fix my margin? What is non-inferiority design margin? So if you cannot find any margin, the maximum allowed margin is 20%. So 20% of your P or 20% of your V, so for example, zero conversion rate, that if you have no idea how to fix the margin, the rule of thumb says that you can go up to 80%, 20% of 90%, this is 18%. But they wanted to have a strict 5%. Okay. This is just a rule of thumb, but usually this is very broad. And just see how you can fix the margin. Now I am going to display the graphs. So you need to answer the question. What?
Superiority.
How many people are voting for superiority? Okay, superiority. Okay, significantly superior. Many times what happens is, why it is called significantly superior, and there is one delta. To prove superiority, it has to exceed 0. Null hypothesis value is 0 when you want to prove superiority. One is better. We say 0 is a null hypothesis, alternative hypothesis not 0. So we come here. How do we come here? Different. Classical control trial. Do we do classical control trial? Many times we do classical. Classical control trial. What we usually do is, there is some effect due to placebo. You put that margin as 5%. Then you won't say your net effect has to be greater than the placebo. That is why the delta comes. That is how we designed it. Typically, they say that if you sit in the WHO, you have to be very strict in designing this. Then academic institutions, you don't really placebo. More the people in IR, they get confused. Simply say that no different from 0. If you wanted to have, the software has the facility to do that, but let us not discuss about it. Now, the next one is, this is superior. I have given the answer. Equivalent. Let us see what it is. Not superior. Maybe that you see the delta S is meaning the superior or whatever. And this is not superior. That is what I expected from you, because the difference overlaps the 0. Okay. This is, now the question is whether suggest equivalence or not. Have I given you equivalence margin? I have not given you the equivalence margin. So I have given you the superiority margin. So that usually you don't look at it. This is the equivalence margin. Tell me what is happening. Equivalent? Not equivalent. But this side of the margin exceeded the limit, therefore it is not equivalent. Okay? And this is equivalent because it falls between these two limits. This one is non-inferiority margins. The moment I say non-inferiority, you should wake up and look at only the lower side of the confidence interval. So this is non-inferiority region. Oh, where is the graph? The line is not there. Oh, here. It says the line has come here. It should go there. Can you see this line here? Yes. So non-inferior because it falls within between this limit. This lower limit is within this limit. Therefore, it is non-inferior. Okay. Inferior, definitely inferior. Inferior? Yeah. This is a summary of all these things. This is too detailed. Okay. And the slides have been circulated to you. As, you have the slides. No. Okay. They'll mail to you. This is from Srikanth Bangdiwala. So he has written this paper. So I would ask you to remember the 8 lines. Okay. This is 12 lines. These are 12 lines. So just say that whether you have fixed your margin, whether the lower limit exceeded for a non-inferiority, superiority has he exceeded the 0, not including 0, and equivalence it falls between the two limits. That is all you have to remember. Okay. Then rest will be easy to look at. Okay. This is very difficult for many people. Don't know how to read this confidence interval. That is where the problem comes. So the important ingredient in defining a non-inferiority is, please remember, a priori one intervention is inferior. I showed you many examples. Okay, that is all we have.